So today we have a NUCLEO-L476RG card here, and we're going to do some programming, some real-time embedded control stuff. And what I'm going to do today is that we have a 400 Hertz frame time, and we're going to compare using FreeRTOS versus using an interrupt, using a hardware interrupt. So there's two ways you could do real-time programming. You can either use a real-time operating system or set up some hardware interrupts to set your frame rate. So the way I'm going to test this out is that I have a waveform generator that's providing a 40 Hertz sine wave. It has an amplitude of plus or minus 1 volt or 2 volts amplitude and a 1.5 volt offset. So the yellow line is the output of the waveform generator, and I have that feeding into an analog to digital converter that's on that board, and the board also has a digital to analog converter, so it's an analog to digital converter wrapping to a digital analog converter. So that's the blue line. So the blue line is the output of the DAC, the digital analog converter, and it has a 400 Hertz update rate, and so it's reading a 40 Hertz sine wave. And as you can see, there's not much of a process delay. I don't really have anything else in between in the code, so there isn't much of a process delay, but I am going to add some software at a later point, and there will be a process delay. But anyway, this is just initial test comparing FreeRTOS to using hardware interrupts. And what I have, the purple line, let me see if I could zoom in on that a little bit. Let's see, we'll change the trigger here. So it triggers off of that on channel 3. And yeah, I don't know if you could see the blips, but they're nice and stable. They're showing that it's a 400 Hertz update rate. So anyway, so what I'm going to show you is a setup from scratch, how to do it using FreeRTOS, and then how to do it using a hardware interrupt. So hopefully you can learn how to do this also if you're interested in doing real-time embedded control systems. So the other thing I wanted to show you is my waveform generator. So this is a Fuel Tech waveform generator that's putting out the waveform into that board. So the first example we're going to do is the one that uses FreeRTOS. So we're going to open up our STM Cube version 1.10.0 and begin this project. So we're going to close our old project. And begin a new project. So this board is a Nucleo board. So we're going to first select that. So here it is here. So it's the NUCLEO-L476RG. And the project name here is called, we're going to put that in. Sample 4, Rev 1. And we want to initialize all the peripherals to the default mode. And there it is. So this is our pinout view for the part. So we're going to add the things. I'm going to add the analog to digital converters here. So we're going to pick 6 of them. They're like kind of multiplexed, but it's all in ADC1. So there's N3, N4, N5, N6. We're going to add the DACs here. And this is going to be our ticker. So we have a 400 hertz frame time. So that's going to put out a little pulse that we could look at on the oscilloscope. So that's the GPIO output. So it looks like we got everything. We're going to use the UART. This is the virtual COM port. So we're going to set that up so we could look at some data, instrument things a little bit. And so so what we're going to do now is add our A to D converter. So we'll work this a little bit at a time. So we have 6 of them. And I like to set up a to D and D to A just so we could see the process delay on a oscilloscope just to make sure things are working. So we're going to set up 6 of these, whether we use them or not. So this one, we have six of them. We have to let the system know that. And we're going to use DMA. So we're going to add this to the DMA stream. And we want to use circular and use full words here. So yeah, let's go back to our parameters now. So we want yeah, we want to do it at the end of the sequence, and we have we want to enable our DMA, and it's in a scan mode, and we want to do so the trigger, we want to do it off of timer 3, and we want to do it on the rising and falling edges. So this, even though like it's a 400 hertz update, this will it'll double the sampling. So it'll guarantee we'll get a sample at least for every frame if we sample it twice. Now we want to do our DACs. I think the only thing we have to do for the DACs are connect to external pin, and I think everything else is good to go there. So we want to look at our timer. So we need to set up this timer 3 because of the DACs. So the clock source is internal, and we're going to do this output compare, no output. So to get we need to get a 400 hertz update rate. So we're going to set this to 49. It's 80 megahertz clock, and this is going to be 3999. So if you take you add 1 to these, so that's 4050. You take 80 megahertz divided by 4,000 divided by 50. That gives us the 400 hertz. So we want to do this on this timer here, output compare. And the other thing, we want to toggle on match. So I believe we have everything, yeah, everything we need there for the timer. So we're going to check our UART out. So I believe, yeah, these default settings are good for us. Nothing to change there. Okay, so now here's FreeRTOS. So we're going to go to FreeRTOS. And we want to use our CMOS version 1. So what do we need here? I found it's okay to enable this. And our tick rate is going to be 1,000. So that's good. And I believe everything else in here is fine. So we need to add a task where we only have one task here. So we're gonna just edit this one, and we're gonna call task 01. There's only one task, and we're gonna change this, just the name here, the task 01, start task 01, normal priority. So I believe, I know this advanced settings, we want to make this enabled, this use new lib reentrance. Let's see what else we need to do here. There's nothing, I believe, okay, include parameters. So we're going to use this vtask delay until, so we want to make sure that's enabled. So that's good there. So the so I'm going to close up some of these. So our system core on our sys, we want to just change this to rather than use sys-tick, we're just going to use timer 2 for this. So now we're going to go around and just look around here. Maybe look at our system view. I just want to check NVIC. Okay, let's see. Okay. 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 Okay, we just want to take a look at this real fast. And we want to, a lot of this is automatic. So I believe everything is good there. So sometimes you have to take this a little bit at a time. And I believe our GPIO is good. And so we could go on and try to generate the template that we need for our code. So we'll give that a shot. We might have to come back to this if it doesn't work out. So, but we'll give this a shot. So the way to do it is just by saving this, and it's going to generate, start generating the templates. So we'll let it do that. The next thing I want to do is to start to insert the code that I had done before. So I'm going to cut and paste that from Notebook++. So so it saves everything between these like user code. So if you have to rebuild the template, it'll save everything between these user code statements. So these are my my includes. So I'm gonna cut and paste them in here. And it's mostly comments. So this is my PV section. I believe it's private variables. So I'm going to cut and paste that. So I have a user code section 2, and this was mostly for these instrumentation buffers to give me some test data and does all the starts. So when I go get that code and move it into here, section 2, and now I have to put the code for the task. I only have one task here that it's got a 400 hertz update rate. So I have to find that. Okay, it begins here. So it's this for loop here. It's in section 5 here. So I'm going to cut and paste that out. Copy. So I'm going to go down here and find section 5. It's right in here. It gives you like a blank 4. So I'm going to substitute it for this 4, and I believe all that got in there. So that looks good. So I have to do some things in this project for the compiler. So one of the things I want to do is in the settings here, let's see. Okay. Okay, so yeah, okay, it's this MCU settings because I do some printfs for the UART, so I want to make sure that's checked. I want to apply that. Yeah, the next thing I wanted to do is I wanted to get this include path for the ARM library. So I have it over here. So I have to include this. It's this ARM math to let the compiler know where that is. So I'm going to copy that and go back to project properties. And I believe it's over here. I have to add this include path. So anyway, I'm going to give this a shot. We'll give it a build and see how it goes. So great, no errors, no warnings. So this board is already connected. So the way to program it is you want to hit this debug. So I'm going to hit that, and everything looks good there. So we'll put it into debug mode, and we're going to try to test this out see if it works. So it's a 400 hertz frame time. So this is the debugger. So it starts you off on this HAL init. So you just want to hit this to resume. So I have a live expression set up with the frame counter. So this frame counter updates 400 every second, 400 times, and this is my real time. So these are my ADC signals. So I'm going to we'll take a look at that on the oscilloscope a little bit to see if that looks like it's running well. So the one other thing I wanted to check here is in because it is a 400 hertz update rate in FreeRTOS. I wanted to change my tick rate here to 800. Hope I got that right. Okay, so we'll do that. And we're going to rebuild the template, but not change the code, the user code. I was seeing a little bit of an error on the oscilloscope. So we're going to rebuild the code there. Now go back to debug. That looks a lot better. We'll go take a look at that. So this is the oscilloscope trace, for example, for R1. And as you can see, it looks really nice. The yellow line is the input from the waveform generator that's feeding the analog to digital converter. And the blue line is a wraparound of the output of the digital to analog converter. So they go right on top of each other for a 400 hertz update rate, and there's no process delay there, so everything looks nice there. So this is using FreeRTOS, so that works pretty good, but there is some overhead with that, so we're going to look at it also just using a hardware interrupt next. So now we're going to do the exact same thing. This is using FreeRTOS, but we're going to do the exact same thing now using a hardware interrupt and compare the two. So I'm going to stop this one, terminate this one, and we're going to clean this up a little bit and move on to the next one. We'll close this project. So we're going to make a new project here. So we're going to go to the board selector, and it's NUCLEO-L476RG. That's it there. So this project name is NUCLEO-L476RG example 005R1. So we would initialize the peripherals to the default mode. So this is going to make our template. But this time we're not going to use FreeRTOS. So we're going to set up our A to D converters. Now this is our DAC. And this is just some our ticker here. So we're going to set up our ADC1. We have 6 12-bit analog to digital converters are multiplexed. So we're going to use DMA for this. And it's going to be a circular buffer, full words. So we want to make sure we have 6 converters here. And we want our that enabled, EMA enabled, and scan mode. So our external trigger is let's see, trigger 3, timer 3, rising and falling edge. That's all good. I believe that's all good. We want to go to the DAC, set up our DACs here. Okay, so we want to set up timer 3. So it's internal clock, and this is output compare. So this is going to be to get our 400 hertz update rate. We need this to be 49, and this is going to be for our timer 3999. And we want output compare, and we have to do toggle on match. So this is going to be for our A to D and for our frame counter, 400 hertz frame counter. There's much less software with this because we're not going to be using a real-time operating system. So what else do we need here? We're going to check our UART, and I believe all the defaults are good there for that. Okay, so the one thing we got to do, yeah, we got to set our nested vector interrupt controller. So this timer 3, see, we don't have the real-time operating system now, so that when this timer 3 runs out, we have to set up a ISR, an internet service routine. So we're going to check this, and we're going to set this to 9. Okay. So I believe we got everything here. So we're going to save this, and it's going to generate the template for us. We'll let it generate the template. Now we have to go put the code into our template. So now we got to find our code and put it in. So here it is over here. So we have our user code begin includes. So we're going to go cut and paste that in. And I'm going to make this all available on my website if you want to download this code. So we got our includes in there. So now we got to get to the next section. So the next section is our private variables. So this is a small program. That we're cut and pasting, putting the code into the template. So now we have our user code too. This is all the startups and things you only want to run one time on initialization of the code. So that goes in here. So now we have a while loop. So being this is an interrupt driven system, one that it only runs when the interrupt is not service. There's an interrupt flag. At the very end, we clear the interrupt flag. But the interrupt service routine will set that flag. So we want to put this right in here after the main while. And just want to go back. So it says if the interrupt flag is true, it runs this code. Otherwise, it doesn't. So that's to suffice for the our interrupt service routine. So I don't believe there's anything else. There's no other code in here. But the one other thing we do have to do is we have to set up our interrupt service routine. So we'll go get that. So it goes into this file here. So we'll have to borrow a little thing from here for timer 3. So the one thing we want to do is get our user code begin here, begin 0, and plug that in. It just initializes this flag. And then I want to look at timer 3 here. So I guess I say in these interrupt service routines, you want to put a minimal amount of code. You can actually put all your code into that also. And I found that it does run pretty much the same, but it goes against the normal convention of doing things. So anyway, so we got that set up, and we'll save all our files. So like in the previous project, we have to set a few things up. So we want to use float with these printf and scanf, because when we write to the UART, we use those in this program, and then we have to include this path again for ARM math. So we want to go over here and add that to our include path for the compiler. So that'll do that. Okay, so one other thing, let's see. Okay, that's our stuff. Just wanted to change the title of this example. It's actually example 5R1. Just want to get that right. So we'll save the files. So now we'll do a build. At least compile all the code. Compiled, so now we want to load it into our processor by going to debug. So that's going to load it into the processor, and it uses the same live watch as before. You don't want to get ahead of yourself in this. You want to wait till it starts at HAL init. I'll put the live expression here and we'll run that. It does appear to be running, and I'm going to check the oscilloscope. So that looks pretty good there. And we'll go look at the oscilloscope again. So we're looking at the oscilloscope now for an interrupt-driven 400 Hz frame, and that looks pretty good there. Looking at the waveform, so the yellow line again is the input from the waveform generator. It's going into an analog to digital converter, and the blue line is the output of the DAC, the digital and analog converter. There's not much of a process delay because I don't really have much code in there right now. So as you put code in, you'll see a delay between the blue and the yellow come into play. There'll be a little extra process delay, which adds a little lag to the system. So you want to minimize the lag in your system, especially when you do things with robotics or designing quadcopters, that type of thing. Anyway, that was a comparison between using FreeRTOS, using the real-time operating system to set up your frame versus using an interrupt. So it's pretty neat. You could see on live count, this is our frame counter. So this updates 400 times a second, and this is our time, our real time, and this is the signals from the ADC, signal coming out of the DAC. So anyway, I hope you enjoyed this and you got something out of this. If you're interested in doing working on the STM32 systems, and they've gone a long way with using STM32 CubeIDE. It's all free. It's great for hobbyists if you're just interested in doing these type of things without having to put a whole lot of money into it. So talk to you later now. Bye.